Okay, in this example, the wearing qualities of two types of automobile tires. Now here we have two types of automobile tires, means we have two different populations. Were compared by road testing samples of N1 is equal to N2 is equal to 100 tires for each type, and recording the number of miles until wear out, defined as specific amount of tire wear. Okay, the test results are given in the following table. We have to estimate mu1 minus mu2, which is the difference in mean miles to wear out, means the difference of population means, by using 99% confidence interval. And we also have to tell, is there any difference in the average wearing quality of two types of tires. Okay, the data is given in the following table. X1 is a sample mean of population 1, and x2 bar is a the sample mean of population 2. So the parameter we are studying here is mu, difference of population means, and the point estimator is x bar 1 minus x2 bar. So this is the difference of the sample means. It can be calculated as using the data given in the table. X1 bar minus x2 bar is 26,400 miles minus 25,100 miles. It will be equal to 1,300 miles. So the average of the difference of the averages of two samples on two populations is 1,300 miles. Now standard error for this difference of sample means can be estimated as follows. We know the formula: s1 square over n1 plus s2 square over n2 whole square root. We just insert values given in table, and after calculating it, the answer should be 184.4 miles. So the standard error in our measurement is 184.4 miles. Now we have to construct a 99% confidence interval. For 99% confidence interval, we can write it like this: the difference in the means, sample means, plus minus z alpha over 2, and this alpha I will show you how it is 0.005 times the standard error. So this alpha over 2 is 0.005. It is from the normal distribution, as we did before in the other example. We draw population normal probability distribution. We know the center will be at z is equal to 0, or average of the population, or population mean. Okay, so 99% confidence interval is the 99% area under the curve. Rest of the 1% is distributed on each side, which will be labeled as alpha half positive and alpha half on the others on the negative side. On the left side is negative of z is negative, on the right side of z is equal to 0 is positive. We know that total area under the normal curve is equal to 1. Therefore, on the left side, 0.5% of 1 is 0.005, and on the right side as well, it should be equal to 0.005. So the area under the curve, which is shaded red, is equal to 0.005. Now we have to find out corresponding value of z for the area which is equal to 0.005 on each side, negative and positive. This is how it is done from the table. Now the table contains all the areas under the curve, and on the leftmost column and the topmost row are the values of z. Now we have to find out on the left side, means the negative side, which should be equal to 0.005. So these are the two values. If we round them off, it will become 0.005. But let's take this one, 0.0049, which is closest to 0.5. So it will make up minus 2.58. Okay, this is the value that you consider that we have found out from the table. Now we have to locate a value on the right side, on the positive side. And for the positive side, it should be 1 minus 0.005, and it will be we should be looking for now 0.9950, and it should also be the same like minus 2.58, but with the opposite sign. It should be plus 0.58. Now let's see what is that plus 0.58. It is 0.9951. Okay, so we can take this value 0.9951, which is also 2.58. Fine, so plus 2.58 and minus 2.58 are the values of plus and minus z alpha 0.005. Okay, now we can insert that value and the value of others in this expression. So the difference of sample means was 1300, and plus minus z 0.005 is 2.58. Standard error is just calculated 184.4 miles. So our confidence interval will become 824 and 475.8 plus 1300 is 775.8. So this is our 99% confidence interval of the population mean. Now we have calculated this confidence interval. Now we have to tell if there is a difference in the mean miles covered by the two types of tires before wearing out. Since the difference in the population means mu1 and mu2 is not equal to 0, it means that the average distances traveled by two types of tires is not the same. These are difference, which indicate that the quality of both tires is different.